Okay, so the tests are back. It was not pretty. The mean on this test was a 63. So things didn't go that hot. If your grade isn't that high, well, you're not alone exactly. So we're going to do something about this. We're going to go over the test today. And then next Wednesday, a week from today, I'm going to have a bonus test for you all. So the bonus test will be exclusively about singly linked lists. And you'll have a chance to earn 30 additional points, which I will in effect add to this score. So wherever you're at, picture in your imagination that number plus 30, no ceiling, and that's what it could potentially become. So if you're not happy with your grade, and few of you have any reason to be, you'll have an opportunity to turn it into something that I think you're going to feel better about. But it's going to take some extra work, and that's going to be really our focus today. I'm going to go over the test. And then the rest of today, we are going to practice linked lists. We are going to think really hard about linked lists today. I know from the lab yesterday that it was pretty clear that some of you are just not very comfortable with them. And so we're going to address that by practicing more and incentivizing it by giving you a chance to raise your grades on this test. So that is the overall shape of the direction we're going. Any questions before we launch into a review of the test? Okay, so here we go. So the first question, the following program contains errors. Identify each error and describe a repair. Let me blow up the font on this a bit and make this a bit bigger. Okay, so tell me, what are some errors here? Anybody? Right, so this business here with the not equal quit, the double equal pre, those both needed to be changed to dot equals. In this case, you wanted to say while not line dot equals quit, and then down here if line dot substring dot equals pre. Okay, so that's two of the mistakes. There were three more. Any thoughts? Yes, Pam. Line doesn't have a type, right? So line needs a data type declared. Specifically, string is what I would recommend. Good. That's three. There are two more errors. Two more. One of them nobody found, but one of them was identified by at least one or two people. Yes, Graham.
For if line.substring 0, 2, that should be changed to a 3.
Exactly, yeah. So this has this off by one business going on. You need to say line.substring 0.3, it goes one, you have to say one past where you want to go. And then the last error, which nobody found, was if the line has fewer than 3 characters, when you try to get the substring, it'll give you an error, and so you need to make sure it's at least 3 characters long. Any questions on that one? Okay. Number 2. For each situation below, state the most appropriate data structure to employ and briefly explain why. Maintain multiple overlapping sets of directions to a destination. For that, you want a singly linked list. So let me sketch out for you why that is what you want. So you have some destination, and there might be multiple ways to get there that ultimately converge, right? Because once you get towards the end, they kind of come together. And so with a singly linked list, those paths can share that last leg towards the destination. And it branches out further than that, right? You can imagine multiple alternatives sharing common paths going quite a ways out. So this question was really about the degree to which you were paying attention to and integrating and thinking about the idea of a trail from Lab 3. The next question, maintain a list of orders in a restaurant so that orders are delivered in the order that they were received. I think all of you got this. It's a queue. It's a queue. C, maintain a list of photographs in which the most recently taken photograph is accessed first. This particular question was inspired by my own experiences with my phone. You know, whenever I take pictures and then look them back up, it's like the most recent ones pop up first. And again, most of you got this correct. It is a stack. Maintain a list of names where each name is consecutively numbered and should be retrievable using that number. Again, most of you got this. This would be an array. An array. Any questions on number 2? Okay. Number 3, you are implementing a program to simulate the participants in a military conflict. For each of the elements listed below, state whether a class, enum, or interface would be the most appropriate way to represent this in Java. Briefly justify each answer. Do not write any code. So the squadron of soldiers, each of which has different capabilities for movement and calculating paths and trajectories. For that, you want an interface. You want an interface. Why an interface? Having a general interface for soldier lets specific kinds of soldiers that have these different capabilities and so forth be represented by specific classes. So you might imagine having a class of veteran that is able to move faster and calculate better paths than, say, somebody green. B, a weapon, which can be a rifle, pistol, or a spear. Just about all of you got this. This would be an enum. We have a small, finite group of possibilities, which we can readily enumerate. A battle tank containing a pilot and a certain amount of ammunition and located at a specific place. You would use a class for this. So specifically, it's a tank, and this is precisely how it's represented. For that, you want a class. Any questions? Okay. Number 4, implement the class prequence. It can only use a string array and an integer as its data representation. It must use the provided constructor implementation, and it must pass these unit tests. Beyond these constraints, you can implement it however you like. So, for the size method, what I was looking for is return size. In other words, as long as you're maintaining this variable with an accurate count of the total contents, return size should do the trick. For capacity, I was looking for return strings.length. That said, I gave full credit to several of you who interpreted this as the method that resizes the array. So in particular, there wasn't really anything about capacity on the unit test. So if you did it that way and the class basically worked as a result, I just gave you full credit for that, because in retrospect, that was under constrained. ToString and add front were kind of interlinked, right? So for ToString, the strategy you use there depends on how you implemented add front. I think just about all of you did this by doing a forward loop through the array and then accumulating a string accordingly and returning it. And that was fine as long as you did add front the right way. The key thing, of course, was to make sure that you looped relative to the size and not to the capacity. Add front, most of you who did this correctly, which was some of you, moved everything aside. So moved everything forward by 1 and then put the new value at index 0. Note that to do this correctly, you have to start with the last item and scoot it over so that you can make space for the first one. An alternative implementation, which I don't think anybody did, but which I had in mind when I created the problem, was for add front to just add to the end of the array and then to string go backwards through it to show everything. And but correctness was the strict criterion. You didn't have to do it that way to get full credit. Any questions on number 4? All right, number 5 was this linked list problem. Basically, nobody got it fully correct. So we're going to go over it now in considerable detail. So what I'm going to do is we're going to go over here to list demo, and I'm going to create a class called node, which is going to look an awful lot like this. So yeah. So I'm going to copy this into IntelliJ. Basically, if you had anything vaguely resembling a working solution, I tried to give you as many points as I could, was my approach on this problem. This copied and pasted in not quite the manner that I anticipated. So let's clean this up. This will just take a moment. Okay, so lose alternate nodes. So the idea was to remove from the list alternate nodes. And so we have a couple examples. If the list contains A, B, C, D, E, calling lose alternate nodes will result in the list A, C, E. So you keep the first node, remove the second node, keep the third node, remove the fourth node, and so forth. Then I gave a second example with an even number of nodes so you could have visualized what would happen in that case. We had an odd number and an even number, which this was a hint. You have to do slightly different things in those two cases. So let's imagine what this is going to look like. In general, let's think first about doing this recursively. If we think about doing this recursively, how many different base cases would we have? What are the simplest possible cases? You can name even one of them if you'd like. So what's a simplest possible case? What's the smallest list you could possibly have if this runs? 1. Yeah, Elijah, you're right. 1. So let's imagine a base case with exactly 1 node. So in that, how do we identify that we're in that case? We have exactly 1 node. How do we know that? I'm sorry? The next is null. Good. So if the next one is null, do we have any work to do? Not really, no, because we're always keeping the first node. So we're just going to leave it like that. Now, what's another base case that we might have to consider? So we've considered one. What might be another base case to consider if we've already considered length of one? We know we can't consider 0 because this object would be null. We've considered 1. What else might we consider? 2! Exactly. Exactly. So we could say something like this. If next dot next is equal to null, then we would just assign, whoops, next to be null. So we eliminate that node. Otherwise, we have more than that. So we've got a nice base case in place. What might a recursive case look like? Thoughts? Let's think about it in sketch terms and see where this takes us. I had an interesting conversation with one of you yesterday in the lab where the conversation went, after we drew some things out, everything made sense. And the student said, I'm being stubborn. I don't want to write things out. And my reply was, don't think with a hand tied behind your back. Use the visual thinking capacity of your brain to help you. Okay, so the first case was this. There was nothing to do. The second case was this. And so the way we did this was point here and get rid of that. Now, let's imagine we have something really long. And let's imagine that you're over here. To eliminate alternates, what needs to change? To eliminate the first alternate, what needs to change? I'm sorry? I would have to move the third one into the second spot. Now, how do I do that in terms of these pointers? What pointer assignment can I make to get rid of that node? The first one would have to point at the third one, right? So instead of having it point there, we would want it to point there. So the variable that we're changing is next. And where we want it to point is to next dot next. In other words, you ask the next one here, give me your next. And that's what I want to point to. So in code terms, I can do something like this. I can say next equals next dot next, followed by next dot lose alternate nodes. So then I just ask it to do it recursively for the rest of it. So let's try this out. So I'm going to create a unit test. And I want it to be a JUnit 4 test. And I want JUnit in my module. So I'm going to create a test method, public void test remove alternate. Something like this. I want things to be visible. Okay. All right. So something that I do want to do to make it easier to write my tests is to be able to represent my string or my list as a string and then automatically build a list from it. That seems to me like a nice thing to create. So I'm going to come back here and invent such a method. So I'm going to call it public static node create from string values. And so here's how this is going to work. I'm going to take my string of values, which will just be space separated strings. I'm going to split it into an array. Okay. So I will say something like string node values equals values dot split on the space character. Okay. Now I want to build a linked list from this. Okay. So to begin with, I need to have some initial value, which I'm just going to make null. Okay. So that's going to be what the end of the list points to. Now I'm going to write a for loop. I'm going to start the for loop at the very end of my array. I have to build this backwards. Why might I be building this backwards? Any thoughts? Because I'm totally going to do it. I'm going to build it backwards. Why might I be inclined to build this backwards? All right, let's sketch it out and picture it for a moment. Let's say I want to turn A, B, C into a linked list. As a linked list, it looks something like this. A points to B, points to C, and that points to null. I'm suggesting I need to build it backwards, starting at C. Why might I want to build it backwards? Yeah, Paxton.
Because C has to start pointing at null. You can't start at A and then say points at B, because B is not a thing.
Yeah, it's easier to start at the end, because what I can do is I can create a node for C, and I can say point at the rest of the list, which initially is null. Then I can allocate B and say point at the rest of the list, which is just C. And I can allocate A and say point at the rest of the list. And so by building it right to left, it's easier to construct. So it's actually not impossible to do the other way. And ultimately, we're going to do it both ways for practice. But for now, this is the way I'd like to do it. So what I can say on each iteration as a result is a new node consisting of node values of I, comma, whatever result was. So initially, it's this empty list. Each time I start at the right and go left, and I create a new node that points at the thing that was there. The thing that was there. And so in this way, I build it up in a manner that has a recursive structure, right? Because what I'm doing is I'm saying each step of building my list just consists of add the current node as the start of whatever I already have for my list. And so this is a really powerful strategy and really very effective. So then I will return that result. Now, ultimately, to know what I'm doing, I want to be able to convert it back to a string. Right? So I can create something from a string, and I want to send it back out to a string so that when I do my assertions in my unit tests, I've got a nice basis for comparison. Okay? So I'm going to create a toString method along the following lines. We'll start with that, or not necessarily. So we've done this before with a linked list, actually. So somebody remind me how we might create a string from a linked list. Remember, we've done this before. Should be old hat. Anybody remember how to do this? It's been a while, but we clearly need the refresher. So, anybody remember how to do this? Let's see. Would you all prefer, we'll take a vote. Would we all prefer to do it iteratively or recursively? So with a for loop or with recursion? Anybody who prefers a for loop, raise your hand. All right, anybody who prefers recursion, raise your hand. All right, recursion has it. So Elijah, you raised your hand. Can you get us started with the recursion? So it would be a base case. Okay, so thinking about recursion, the base case is the simplest thing we can imagine. What's the simplest thing we can imagine? How many, yeah, Paxton.
List where it's just one node.
Where it's just one node. And how do we detect that? If next is null. So if next is null, what are we going to return? For surely we are going to return something. We're going to return something really simple. You know what? I'm going to scoot this up actually so that you can see the data representation for the class. I'm going to put it all the way up here. So looking up here at what data is present in the class, if the node has no successor and we're converting it to a string, what are we going to return? What? Value. Good. Good. Very good. All right. So next is now not null. This is the recursive case. It's still pretty straightforward. So I'm just going to type return right here. So what am I going to return? There are three pieces. What's the first piece of what I'm going to return? Value. Good. And I'm going to concatenate it to something. What's that something going to be? We'll go with a space. And we're going to go with a space because we're mirroring this structure down here. Okay. And what's the last thing I'm going to return? Good, good, good. Next dot toString. Bam. So we take the current value, we add a space, and then we just ask the rest of the list to turn itself into a string. So now we really have something we can work with in terms of writing a unit test. We have to have a way of specifying what the structure of the list should be beforehand and afterward. So we're going to use what we saw in the statement of the problem. So we'll start with the ABCDE example. So we're going to create a node L1 equals node.create from ABCDE. Oops. Then what we're going to do is say L1.lose alternate nodes. Now we can put in an assertion. So we can assert equals ACE, comma, L1.toString. So when we convert L1 to a string, that's what we should have if our solution works. So no time like the present. Let's find out if it works. So I'm going to run node test. IntelliJ needs a cup of coffee this morning. strong coffee. Okay, it passed. So now we're going to add another test, which is the longer example. A, B, C, D, E, F, G, H. Oops. L2 dot lose alternate nodes, and now we should have A, C, E, G, comma L2 dot toString. And let's try that out. Whoops. Let me try that again. I hit the wrong button. Okay, that works. That works. So coming back here to our solution, there it is. There it is. Really pretty straightforward. Any questions on this problem? All right. So here is what we're going to do next. We are going to come up with some other methods to create to give you all some practice. Here is the first such method. Public void remove last. Actually, let's go ahead and have it be a string. There we go. So this is what you have to do. I want you to write a method that travels all the way down the list till it gets to the end. And when it reaches the end, it should delete that last node and then return the value to the caller. You may assume that your list has at least 2 elements. Assume that your list has at least 2 elements. So go ahead and take 5 minutes and see what you can come up with, and then we will try it out. In the meantime, I am going to work on some unit tests as well to set this up. Okay, do we have any volunteers ready to share their remove last? Any volunteers? I can see you writing. I know there are things to share. So Ivy, why don't you share what you have? Uh-huh. Okay. Okay. So we do have one little missing ingredient, which is that we want to return that value. And the reason I'm bringing it up is because if we don't, it's not going to compile. So let's just slightly tweak it to do that, and then we'll try the test. So Ivy, can you think about how we might tweak it to return that value that we've removed? So we've just set next to be null, so we can't really return it. So what we need is a temporary variable, right? So we can say something like this: string temp equals, what would this be equal to? Anybody? Next dot value, good. And then we can return temp. And then down here, we just return whatever we got from there. So let's try it out. I'm going to go over to node test. And it did get its coffee. It ran. And the test passes. So something I really want to highlight here is how Ivy really nailed this structurally. That is, I said, I'm giving you the assumption that you've got at least two elements. So that means your base case is when you have exactly two elements. And note how she correctly determined that with this well-formulated condition. If next.next equals null, then we're down to the two elements. Part of why this works is I said, just assume at least two. If you had to consider that there would be only one, it would be hard to make sense of this because it's hard to imagine something removing itself. But with that assumption, it was able to work pretty well. And so this is a really nice solution. Well done. Well done. All right, so let's create its evil twin. So public void add to end string s. So add to end is going to take some string value, and then it's going to march all the way to the end of the list and create a new node there containing that value. You can assume you already have at least one value in the list. So take a few minutes, try it out. Let's see what you come up with. And as you're working on add to end, I will work on the unit test. All right, do I have a volunteer for add to end? Volunteer for add to Tate, what do you have? Let's try it out. Let's try it out, see if it works. That too is correct. So let's explore its structure. If next.next is equal to null, then we set next.next to be a new node, which itself is null. And then otherwise, we just do it recursively. Now, I'm feeling slightly curious about something, so I'm actually going to add one more test, just for amusement's sake. I'm going to create a node with, or a list with one node, and then I will add to end the letter B, and I will assert equals AB L2.toString. I'm going to try this out. Oh, and it sadly failed. It sadly failed. So, what was my intuition here? And this is something that can be a really good strategy when you're testing, is to think about like what are called boundary cases or extreme cases and make sure that it works even in those. Those are often easy places to mess up. In this case, the basic logic is absolutely correct. It's just that it is more restrictive than it needs to be. Instead of next.next, we can actually just use next. So in other words, because we can have a list with just one node, we can just see if next is null. This had a more relaxed situation than the other example. So it was easy to fall into this because the other way of doing it, we were like, when we're removing, we needed at least two, but when we're adding, we only needed one. So now, with that ever so slight modification, it now passes the somewhat more aggressive test that we had here. But other than that, the structure was completely dead on correct, right? You figure out if you're at the end. If you are, create a new node. Otherwise, just recursively ask it to do that. So just to recap, here's the plan from here. Like we talked about, the tests were not good. In general, people struggled with them. And I observed in lab yesterday, one of the reasons for this is in general, the class hasn't reached the comfort level with linked lists that we need to have. The solution to both things then is a week from today, I'm going to have a bonus test strictly about linked lists that will be worth 30 points, which can be added to your score on this test. So wherever you're at, imagine that plus 30, and you're probably in a happier place, okay? To this end, we're going to keep doing some new material on Friday and Monday, but I'm going to start class on each of Friday and Monday with one or two linked list problems to get you practicing. Beyond that, I encourage you all to make up your own problems and then try them out and see how you can do. And you can follow the basic methodology that I illustrated today. That is, come up with a concept, then based on that concept, write a unit test to see if it would work. Once you've done that, try coding the method until it passes the unit test you came up with to assess it. So like I said, I'll have one or two of these at the start of class each of Friday and Monday, and then Wednesday we're just going to go all out on this. But then also on Friday and Monday, we've got some new material that we're also going to be covering in order to keep the class moving. So, any questions? All right, good. Practice linked listing, and I will look forward to seeing you all Friday.